Those, they're not equally spaced, or they're, well, I guess they are, but they're not. They're odd numbers.
Different sectors.
On the right track. What's in the middle?
Oh, the center point.
What's center point?
The G54.
Our origin, our datum, our zeros, Cartesian coordinates are in the middle here.
So datum is another way to say origin.
Yep. So it tells us in our problem that the center of the circle equals x0, y0. These lines are going to be used as reference lines. What do you know about those lines?
Oh, the coordinates. You got coordinates, 4 coordinates. Oh, they're 90-degree
They're
angle.
all 90 degrees apart from each other. Right? So when you do one of these problems, the first thing you want to do is draw the Cartesian coordinate system. And label. Label each line. We're going to label them 0, 90, 180, and 270. So you need to look at the problem. At the bottom, what does it tell you? You've got hole count. There's 3 holes on this ball circle. What else does it tell you?
The diameter is 6.
Ball circle diameter is 6. And then rotate angle 10. The first hole has been rotated 10 degrees from where?
Origin.
From that center line that we just drew in. So where are we going to put 0?
On the straight line.
On the straight line here. And then we know each reference line is 90 degrees from each other. So we've got the horizontal line going to 3 o'clock as our 0. Vertical line going to 12 o'clock as 90 degrees. What is this reference line going to be?
180.
180 degrees. And then this reference line, 270.
Like a compass.
0, 90, 180, 270. Any questions on what we're doing here?
Oh, I just have a question now. Why is it 270 instead of 360 degrees?
So from this line, how far is it to this line?
90 degrees.
360 would be the whole circle. But we're stopping here. So what is the distance from here to this line? 90. So 90 subtracted from 360 will give you 270. So the first thing you want to do is draw the Cartesian coordinate system. Step 2. Start to calculate your angles. So what do we know about the angles on this particular part?
They're 90 degrees apart.
Sure?
Oh, well,
How many holes do we have?
3.
When you add all 3 holes together, it's going to equal 360. So you're going to do 360 divided by the number of holes.
Oh, yeah.
That is going to give you the angle between the holes. Holes are equally spaced. If they are not equally spaced, it will tell you so on the problem. By giving you an angle specifically to that hole. Okay? But it doesn't do that, so we have to assume that they are equally spaced. So 360 divided by 3 gives us 120 degrees. So you're going to calculate the angle of each hole from the 0 degrees, the 0 reference line. The first hole is easy because it gives it to you. At the bottom of the page, the problem says the rotate angle is 10 degrees. So we know that hole is 10 degrees from 0. How far is this hole from 0? Well, we know from hole 2 to hole 1 is 120. We just worked that out. 360 divided by 3 plus 10. So how far is hole number 2 from 0?
30.
130 degrees. Hole 3, we got 120 till we get to number 2. Another 120 till we get to number 1. And then 10 to get to the 0. So how far is hole 3 from the 0? 250 degrees.
Yeah.
So as you calculate those angles, this last note here says draw a line from the center of the circle to the center of each hole. So draw a line from the center of the circle, from our 0 to the center of each hole. What is that line called? Someone whispered it, speak up. The center of the circle to the edge of the circle, what's that line called? A radius. How do we get a radius?
Half the
Half
circle.
the diameter. What's the diameter? What does it tell you at the bottom?
125,000.
So the line from the center to each hole is a radius. So we're going to take the diameter divided by 2, and in this case, that is going to give us 3 inches. The bolt circle diameter is 6, divide that by 2, that gives us 3 inches. Most important part that you understand here, the line from the center of the bolt circle to the center of each hole is going to be your hypotenuse of your triangle. So what do we know about our hypotenuse? It's 3 inches. So put that on the print. Almost done. Draw a line from the center of each hole. To one of the reference lines that we created in the first step. 0 degrees, 90 degrees, 180, 270.
So pick one reference line
Doesn't matter.
and
You
then
get the same triangle every time.
and just use the center of every hole to that same reference line.
So from the center of this hole, you've got 2 choices. You can draw a line to this reference line, or you can draw a line to this reference line. Pick one. Doesn't make a difference.
130.
Not the 130. 130 is not our reference line. Our reference lines are 0,
Oh yeah,
90,
the
180, 270.
the 90.
If you draw down or vertically, where it meets the reference line gives you 90 degrees.
Triangle.
You have the angle here,
That's a reference angle.
10 degrees. So this side here would be opposite.
Opposite.
This side here would be
Adjacent.
adjacent. For hole number 2, again, pick a reference line. Do you want the vertical one or the horizontal one? It makes no difference. If you draw down here, that will be your 90 degrees. If you draw this way, that will be your 90 degrees. What's the difference between those 2 triangles?
They're equilateral.
Not equilateral. What's equilateral?
Equal sides. They're,
All 3 sides are the same.
oh, okay. So that's three or
Not
two.
equilateral.
Two.
Those
Right.
2 triangles are what's called congruent.
Okay.
Similar.
Two right triangles, right? Both 3
So
inches.
each time, just draw a vertical line or horizontal line. And that is going to form your right angle triangle. We know the hypotenuse. We can see the triangle now. What's missing? Calculate the angle in the triangle we just created. The first one is given to us, 10 degrees. It's easy. But in the second one, because we drew the line down to here, we've got a line at 180. We've got a line at 130. What's the difference between those 2 lines?
We know there's 180 degrees in a triangle, and we know there's a 90-degree angle right there.
More specifically, this reference line is 180 degrees from zero.
Mm-hmm.
The hypotenuse line that we drew is 130 degrees from zero.
Mm-hmm.
What is it from here to here? 50 degrees.
That's the difference here.
So now you've got a side, you've got an angle. You can use trigonometry to solve the other two sides. Right? At the bottom, because I drew it this way, we've got 250 and 270. 20 degrees between those two lines. If you use this top way to create your triangle, just to show you they're exactly the same, you're doing 130 to 90, so what's your angle? 40. So the one here would be 40, and the one here would be 50. Both triangles are exactly the same.
It's just flipped.
You're just using a different angle, that's all. So just like the sine bar that we covered last week, there are only two things you ever need to work out. The opposite and the adjacent. So to work out the opposite, it's going to be sine of the angle times by the hypotenuse. To work out the adjacent, cosine of the angle times hypotenuse.
They're both times
And this
hypotenuse.
goes back to week 1, what we covered for homework in the test. Label the sides. If you label the sides wrong, you're going to get your answer wrong. So look at your reference angle. That is going to give you the opposite. The side where we put the 3 is the hypotenuse. So the remaining side has to be the adjacent. Reference angle, opposite, and then adjacent, and then at the bottom, reference angle, opposite, and adjacent. Now it's important you understand these sides, because if you put these two numbers the wrong way around, what's going to happen to your part?
Scrap it off.
You're going to scrap it off. If you put x 0.5209, it's going to move to here, and then the y will be up here. You just scrap your part. So double check. Make sure the x and the y are wrote down correctly here. Right? So the opposite is going to give us which side in problem number 1? What axis goes up and down vertically? The y-axis. So sine 10 times 3. How many decimal places are we going to? 4 decimal places.
5209, which is already there.
520 and 9/10. To get the adjacent or the x-axis, you're going to do cosine 10 degrees times 3. Two inches, 954 thousandths, and 4/10. biggest mistake people do is put the X and the Y incorrectly. The second biggest mistake, let's do problem 2 and I'll show you it. To get the opposite, which is going to give us the y-axis again, you're going to do sine 50 times 3, and that gives you 2 inches, 298 thousandths, and 1/10. To get the x, you're going to do cosine 50 times 3. What does it say on your calculator?
1.9284.
You just scrapped your part. Why?
It's not on the right point.
Anything to the left has to be
Negative.
negative. If you do not put the negative in your program, the machine would do that hole here. You just scrapped your part. So you got to think about the quadrants. What do we know about quadrant 1?
It's always positive.
Any hole in this quadrant would be positive. Any hole in quadrant 2, x negative, y positive. Any hole that falls in quadrant 3,
Negative.
both negative.
Y negative, X negative.
And then our final quadrant, quadrant 4.
X positive, Y negative.
Yeah, X positive.
So check. Check your answers. Don't just do it and think you're good. Check. Did you put the X and the Y the correct way? Did you put the negative sign? Should you need it? Because if you mess up like that, you're going to get the answer incorrect. On your homework, each hole is worth 3 points. You're going to get a point for drawing the correct triangle. You're going to get a point for the correct X and a point for the correct Y. So even though there's only 3 holes here, the whole problem is going to give you 9 points total.
Sweet.
Second problem in your packet is 5 holes. So now it's worth 15 points. The third one is 7 holes, 21 points. As long as you follow these procedures, you shouldn't have any problems.
Word.
Yeah, you get the X and the Y. On calculator, when I put sine 10 degrees times 3, I got 0.4693.
Calculator in degrees, or you can make
So, it's 0 to 9,
Everything. Yep. Hopefully when I go home, if I forget anything, I just refer to the video.